Of a one-to-one Ganella balun, and I first of all wanted to show people some of the mistakes that one can make in purchasing constructed baluns from across the pond. This one, for example, it happens to be a 4-to-1 balun. It had an open circuit in it. That just indicates, that the quality control is not quite up to par. This one actually is another one from across the pond as well, and it actually does work. It is a 1-to-1 balun, so you can imagine how large the ferrite is inside it. And this third one is another one that they claim will be a 100 watt maximum, but I just wanted to show everybody what was on the inside of this one. So that is what a 1-to-1 balun looks like when it's completed, and you can see the size is relatively small, and I think it would probably be okay for QRP, but not for really 100 watts. Just to give you an idea of the sort of size we're talking about that is useful for larger amplifiers, and this one happens to be another one that I built that is a 49-to-1 transformer and capable of full maximum power, 1.5 kilowatts. The kit that I wanted to show everybody is this one. It comes from Ultronics. They claim a 1 kilowatt, and this is what the kit looks like inside. So you've got a ferrite core and a roll of wire. There are other kits that come complete with some plastic to sleeve over the top of the wire. This wire happens to be covered with enamel, so it should be okay. The one problem with this particular ferrite core is the edges are fairly sharp. So we're going to have to first take it out of the packet, wrap it. As you can see with these cores that I've purchased for this one, the edges are rounded, so there's no need to cover the ferrite core with electrical tape. And just to give you an idea, that's the cost, $21.56. So excuse me, $23.31 with tax. So that's what it's going to cost you for this part of the kit. In addition, you're going to have to buy some other bits and pieces. So first of all, Home Depot, you can pick up a box like this for approximately 10 bucks. You then need some stainless steel hardware and a few connectors and things like that. So that is really all there is to this. Okay, for clarity, I have used a different wire, manufacturer wire. It comes from Remington. It is the same size, but in order that folks can see the difference between the two wires that we're going to wrap, you can see this one is red and this one is sort of a copper color. We are going to need approximately 1 meter, 1.25 meters maybe of this wire to make this Ganella current choke. So we'll cut ourselves off 1 meter of each of these wires and go from there. As I mentioned before, the edges on this particular ferrite core are a little bit on the sharp side, so using an ounce of prevention rather than a pound of cure, we're just going to complete a wrap, and that is going to soften the edges so that it doesn't cut through the enamel on the wire. Okay, so this is where the fun begins. We take our 2 pieces of wire, we're going to wrap them through one time there, bring them over the top again, and we're going to stop right here for a moment, and in order to retain or not, that's just a joke. So we'll put a tie wrap in there and hold it, and then we'll continue with the other wraps. Okay, as you can see, we've got a number of our wraps on here. On the fifth one, we're going to cross it over and go inside and then come back up, and we'll be wrapping it around in this direction so that we'll have a pair of wires coming out at this end. So when we're done, we should end up with something that resembles this. So you'll see that we've got the 5 wraps here, the 5th one goes underneath, and another 4 wraps continue to the end. So we're going to trim this off right here because we don't need any more than that. And then the next step is to clean the ends up so that we can actually solder them and put on some ring connectors. We'll put on a ring connector like this on the ground, or excuse me, on the 2 devices that we're going to use to attach the antenna to, which are these hooks. Okay, so now the next step of the process is you take your box and your bits and pieces, and of course we need a SO239 type socket, and through the magic of Mel's editing and my sleight of hand, we're going to transform that into that. So as you can see, this is where the 2 wires for the dipole are going to attach to. They'll attach on the inside here to the wires from the toroid. So it'll be like this. One of the wires going here, one of the wires going there, and one of these wires going to the center, and the other one going to a connector on the SO239. So that's the next step. The reason I've left this much on the outside and connected these, because this is going to be used to connect the antenna wire. It will be wrapped through the eye hook here as well, which will take the strain, but this will be the actual connection, and then the nut will be screwed down and it will arrive here. The reason they're out here at the moment is because in order to get the tool, the crimping tool, in there, you needed to have a little more space. Let me demonstrate right here. You see, you need to have more space. If it was any closer than that, I wouldn't be able to crimp the wire in there. So the first step is, once you've cut the wires to the length, you need to scrape this enamel off, because without doing this, you will not have a good electrical connection. So we'll just get this enamel off of here. Okay, that's that one, and we'll go ahead and do the other one. Now that you've got the end of the wire nicely cleaned off and it's going to make good electrical contact, you need to get your crimping tool here, and using the appropriate size, okay, make sure that bond is good, and then we'll go ahead and do the other one. Okay. Oh, of course I've got to do the wire on this end as well. We're just going to clean these ends up as well. Yeah. Okay, as you can see, we've got our connectors for the antenna wires that will connect to these posts. This one is the ground wire, which is going to connect to the SO239, and the next thing we need to do is to tin the wire that's going to connect to the center conductor. And if you don't get this nicely tinned without breathing in the fumes, then it won't make a good connection. Okay, so this is the next phase. We're going to install everything into the box. So we'll get these guys hooked on here first, like that. And if you've got big fat fingers like me, having a pair of thin nose pliers around is also useful. So, alright, we'll get those in place. And we've got to get the nuts to put on there, so that'll be the next thing. I like to put on a washer with a locking nut and center conductor, and insert it like that. And I always find that propping it up like that helps a bunch. Make sure you always, when you're soldering, always have a good clean tip. Another tip is that when you put your iron away, put a bit of solder on there to begin with. It makes it much easier to solder anything later on. You're not waiting for the solder. And there we go. Nice good bond there. Okay. Yeah. At this point, we've now tightened up the two nuts on here, so this end is connected. Both of these ends are connected, and the other end is connected to the ground right here. And we've soldered the center, the second wire to the center pin of the SO239. Some of the kits, even from the same company, come with plastic tubing like this. And rather than enameled wire, it is normal copper wire, and the wire is the plastic tubing is fed over the wire and stops any shorting out or anything like that. So some of the kits are this way. If you don't have enameled wire, can't find it, then you can use regular 14 gauge copper wire out of electrical cable and then slip this over the top of it.
We wanted to include a few definitions. A choke is an inductor that blocks all high-frequency RF signals and only allows DC signals to pass through it. A balun is an acronym for balanced to unbalanced. It usually means connecting a balanced load, such as a dipole antenna, to an unbalanced input, such as a 50-ohm coax cable. The shield side of the cable is usually grounded. A couple of terms that we want to mention that are almost always synonyms: a common mode choke, a line isolator, or a one-to-one balun. Almost always you can use these terms interchangeably. Baluns and chokes can be made with enameled wire, as Jeff demonstrated in this video. It can also be made with wire that is covered with a sleeve, or with coax, and many people like RG142 or RG400 that are both small coaxes. The design used in this particular how-to comes from the ARRL Antenna Handbook. It's called a granilla current balun, and this is exactly the one that Jeff demonstrated. The ARRL Handbook has many ideas on different ways you can construct them, and so we encourage you to look at that. Here's the before and after. Obviously on the left, this is the kit and the parts. On the right is the finished product. Wanted to show a few others. Here's one by JWS7i, and it's made with RG142 coax. Same principle, same number of windings, just with coax instead of using enameled wire. Here's another one without a box, and some people prefer to have them without a box because they dissipate heat better. Here's another one with a different coax, again without a box. And then here's one by Gary, K7GS, and notice it has multiple toroids. This can handle much more power. and it's made with 142 coax. Thank you for watching this video.